Nice to
Nice
meet
to
you.
meet you. Hi, Dave Molyneux.
No, we'll be a
Nice to meet you.
you.
No, this is Kevin, right here.
I guess that's for the finished ones. Okay.
Yeah, that's fine.
Ready? Okay, so, good afternoon. I'm Joe Condon, President and CEO of Auxadyre. Auxadyre was created to bring 20 years of research to market with a patent pending process that we believe redefines foam padding. This innovative technology creates foam with a 600% increase in impact protection and a 50% reduction in pressure points, creating a cost-benefit advantage in most foam pad applications. With limited marketing to date, we are already at level 2 prototype evaluation with 3 of the world's top 10 sports equipment, apparel, and footwear companies, and 1 international military ballistic vest manufacturer. Auxadyre, we believe, is market ready. We've got an experienced veteran management team. We've got a validated manufacturing process. We have protected IP, and we already have next generation technology around smart foam under development. So Auxadyre is seeking startup funding, seed funding, to finish and finalize initial customer designs and provide initial customer orders. So thank you today for your consideration. Okay?
Great, great.
Okay. Someone go ahead and set this so I can at least keep track of myself, if that's okay. Otherwise, you're going to have to see it. Okay.
Should I keep time or
Yeah.
you want me? Okay.
This will go off.
Okay, all right, that'll go
That's
off.
20 minutes?
Okay.
Okay.
Extra points.
So company introduction, again, 20 years of research finally coming to market. We do have a patent pending technology that we believe redefines foam padding in a very broad sense. 3 out of the top 10 worldwide sports equipment, apparel, and footwear companies, level 2 prototypes with all 3 of those. All 3 of those companies contacted us. So again, we've done very limited marketing to date. We have our foam, and the idea of Auxadyre foam creates a performance advantage, and therein lies the magic. Management team are experts in our associated fields. The management team is 15, 20-year veterans in different facets of business. And we're seeking $600,000 of seed funding. Again, we're at phase 2 prototype. Next step will be final product design. We can manipulate material properties for specific applications, and then moving from a prototype process to a hard-tooled mass production process. So the problems that we see that we think this technology answers in the medical device space, there are no foam pads that can address swelling for orthotic pads. There are damaging pressure points in specific applications. There are gaps in coverage. These are actually right off the manufacturer's website, so this is what they advertise. Conventional foam tends to crease. That creates gaps. Those gaps then create pressure points, so it minimizes coverage and creates pressure points where you don't necessarily want them. There are a bunch of technologies I'm sure you're familiar with, gel and high density, or what's called memory foam. They tend to be very heavy and traditionally uncomfortably hot. Foam padding, again, in pinch points, there's very expensive designs to try and deal with bending. Bending is an interesting phenomenon around foam pads. When your elbow or knee or that joint is bent, typically that's when you need the pad to perform at its best. And that's when the foam performs at its worst because of that creasing and providing gaps. In sports protective equipment, similar phenomenon. This is actually a brand new high-end baseball helmet. The photograph was taken at a local sports store. That it was the most expensive baseball helmet we could find. That is a brand new in its ready-to-sell condition. We've got a boy who plays competitive ball, and I'll tell you, if he's on base more than about 15 minutes when he comes off, he has those creases in his forehead. Again, any bending and pinch pointing, when you need the pad, typically elbow and knee pads, are put to use when the joint is bent. That creates all kinds of pinch points and pressure points. This was an article, I'm sure you have all heard in the media, some discussion about concussions in sports. And this is actually a picture of a helmet that was in use. That is a polystyrene type foam. By the way, that's the same general material that's used for insulators and coolers, and now we put it on our heads during an athletic event. The market opportunity. So how big is this market of foam pads? So this is US data only, very hard to get worldwide data, but in the US only, the end market size is the consumer sales of the finished product with foam padding in it. We did an analysis based on some of the publicly traded companies that were able to get access to their financials and worked into their cost of goods sold. So we understand what the retail relationships are. We went through the cost of goods sold. We were able to pick out what we thought was material content as best we could identify. And we think the foam padding in the US, this is the padding, which is Auxadyre's addressable market. We are going to be a business to business. We do not want to get in the helmet or the elbow pad business. We want to sell the foam to those manufacturers. And so we think it's about a $3.6 billion business in the US alone. So what is auxadic foam? What is the science? By definition, if you know anything about engineering or materials properties, there's a phenomenon called Poisson's ratio, where when you put a material in stress, generally most materials will, the cross sections will tend to shrink. Auxadic materials are defined by having a negative Poisson's ratio, which gets you that counterintuitive performance. So when it's in compression rather than bubbling out, the entire structure compresses. And when it's in tension, the entire structure expands out. The science of auxadics has been around for a couple of decades. If you think about Kevlar, that's an auxadic fabric. And when a bullet impacts Kevlar, the reason it doesn't penetrate is at impact, the bullet is putting the fabric in tension. And in tension, the material contracts and the fabrics come tighter together and they do not allow the bullet to penetrate. Auxadic foam has been in laboratories for 20 years and nobody's been able to produce it until now. So, seeing is believing, especially in the day of Photoshop. So these are samples we've made in our prototype lab. You want to take the ends of it and give it a pull and watch what happens to the shape. It's very hard to see the compression, but you can certainly see what happens in tension. Both of the opposite cross sections, both the width and the thickness, expand in tension. You would get that same behavior in compression, just a lot more difficult to see. So the science, often for investors in technology, one of the begging questions is the science real? Does it work? And our answer is absolutely yes, it does work. So, what does that mean for the marketplace? These material properties create a 600% increase in impact absorption as measured in our laboratory, 50% reduction in pressure point stresses, autonomous self-adjusting in medical device braces. If you have a walking brace around your ankle and it's wrapped and you begin to swell, what happens when you press on the foam? It shrinks and allows you more room. And as that swelling goes down and that pressure's taken off, the foam expands back out. So the constant pressure environment that can respond autonomously to swelling and bending. We do have a manufacturing controlled process where we can vary the material properties for specific applications. Obviously, the behavior of foam inside of a football helmet is likely different than in a knee pad, is likely different than in a knee brace. So we can dial in the process and get a whole family of auxadic foams. Dramatic improvement in shear and in indentation. That football helmet failure picture that I showed you off of ABC News, that's actually a shear failure. Dramatic, we haven't been able to measure that yet, but we have a testing machine on order. Crease-free bends. I'm going to take your sample and bend it around in an S shape. You won't find creasing. As you curve around, the inside diameter is in tension, and that small radius naturally shrinks while the outside diameter goes into compression and it naturally expands. So you get perfect radius forming without any creases. It's lightweight and breathable. That is an open cell structure, different than some of the conventional pads. And it is, by the way, we have a sports family of athletes, teenage athletes, and it is machine washable, which is important. So in the market, what does that mean? In prosthetic socks, which is where this technology was originally invented, leg amputees during the course of the day experience about a 10 to 15% swelling phenomenon, a volumetric change in their residual limb over the course of a day. Within a day, about 15% day to day over a period of months, depending on their fluid levels, depending on their weight, depending on all of those variables. 20% is foam. We've shown in a prototype prosthetic sock, we can take a negative 50% up to 120%, so well within the usable range. Creaseless fit, again in the same boot, and you can see around the toe, no pressure points because that radius just forms naturally and beautifully. This is data off of the prosthetic sock prototype that's been built, conventional prosthetic socks, and this is pressure at varying points in the sock. We put an Auxadyre foam sock in, and you can see we're going from a 10 psi down to a 5 psi, and in some cases we're going from 10 psi down to less than 1, and this is on a 180-pound patient. So incredible pressure relieving as well as this volumetric fluctuation. In sports equipment, conventional foam versus Auxadyre foam, we get about a 6.2 multiple of impact protection. So if you impact the foam, how much energy translates through to the opposite surface. And the opposite surface in football helmets and baseball helmets and hockey helmets, and the list goes on and on and on, is your head. And so we can provide 6.2 multiple of impact protection. Again, this is the same idea here with forming, and we get this creaseless, this is one of our prototype helmets. It's actually one of our boys' old helmets that doesn't fit anymore, and there's no creases in that forehead piece at all. Better protection, better fit, a lot more comfort, less weight. Last year, there was an annual conference for international sports engineers. These are the engineers who design sports equipment. And at their international conference, one of the feature presentations was Auxadyre materials for sports applications, an ideal solution for many of the applications not commercially available until Auxadyre. So we believe we are market ready as we sit here today. We have exclusively licensed the technology. I hope I'm not struck by lightning in this form, but it does come from FSU. We have 2 US patents that are pending. One patent is around the manufacturing process to convert the foam from conventional to this Auxadyre phenomenon. And the second patent is the application of this and a handful of other technologies that I told you were under development, and the application in a prosthetic sock with smart foam, and I'll show you what that looks like in a little bit. We do have a validated production process. This did not come out of the laboratory. This came out of our manufacturing process. These did not come from FSU. We built those. We have a fully tooled prototype process. Everything is in place. We're building prototypes today at the second level with 3 major sports companies. We have a veteran expert management team, expert within their field of business. And again, major customer prototype evaluations underway as we speak. In fact, I had a call this morning that our sample shipment to Germany got hung up in customs, and so I needed to release some documents so customs would release them to we're working with Germany and working with a company in Istanbul, Turkey. So, go-to-market timeline, do we have a plan? Yes, we do. 3 major categories of this plan broken down into quarters. There's details behind all of this. First and foremost was entity creation. The licensing agreement and the entity creation started with FSU. We signed the last week of April, so we're still very early stage. Everything in the entity creation, major milestones, is complete with the exception of startup funding. We're still obviously seeking startup funding. We have been bootstrapping to date, and that's fine. We'll continue to do that. Startup funding will allow us to go faster and reach out to customers. So far, every customer that we're working with has called us. We called nobody at this point. Generation 2 is what I call sheet products. We can make Auxadyre foam into sheets. Out of sheets, there are hundreds and hundreds of applications. Medical device bracing and most sports applications start as sheet products. And so we expect revenue in Q1 2016 based on the interaction with those 3 companies we're having today. So we're well down the way. Of capital equipment and development and validation is complete. So Generation 2 capital equipment will be hard tooling following funding. And we'll hard tool and get out a prototype, and we know specifically what these customers want and where to dial in the material properties, the volume commitments will be prepared to hard tool. The next generation is interesting. Again, this research, the original discovery came from a $4.4 million grant from the VA to FSU to create a better solution for leg amputees. With all this swelling phenomenon, and it's hot, and Joe is heavy, and all those problems. So we delivered a working prototype. So we made good on 2 years and $4.4 million of research. About 3 months ago, the Army came back and said, we have $500,000 we're willing to invest. Can you take the working prototype and get prepared for a go-to-market, ready to provide the VA with thousands of prosthetic socks? And the answer was, of course, yes. So what we're doing with FSU is, I said, let me go to market with sheets. I'll be on the team to develop prosthetic socks. I want to make sure that we consider things like design for manufacturability and design for cost. In that market, the price is fixed. In medical device, there's reimbursement rates from your insurance. Leg amputees are entitled to 6 prosthetic socks every 6 months, and there's a fixed price of about $78. So I'm working with FSU and the $500,000 grant from the Army to do the development of that sock. We've got a cost target between $10 and $15 for a product that will sell at $78. So the team, you met me, I'm Joe Condon. My background, I've been a CEO for a prosthetic and orthotic company in Detroit, so I know the landscape well. I've been a vice president and a board member in several major Fortune 100 medical device companies, so I know my way around medical device and large publicly traded companies. If you know anything about the landscape here in Gainesville, I actually ran the RTI operations for about 5 years as the vice president, so got a chance to interact with Jamie Grooms and that team, and that's where a lot of the inspiration came to grab a piece of technology and go, and here we are today. My wife is actually the founder and chief compliance officer. Betsy's background is environmental and safety science, and she, several years ago, was nationally recognized as the Safety Director of the Year in all industries by the federal government. There's a board from OSHA that looks at safety executives, and she was voted Safety Compliance Officer of the Year. Josh Hallberg is our Chief Commercial Officer. He's an award-winning business-to-business sales executive, and he'll continue to work with us until we can bring him on full-time. So we're happy to have him, and he's committed to this team. And Scott Andrews is the Vice President of Operations. He's a senior technician in the medical device. He does installation, maintenance, repair, for surgical equipment. So this is equipment in the OR, high-end electrical, mechanical. I think Scott is absolutely brilliant for this job to make sure that this manufacturing process stays on cost, on quality. We all are very active in the community, I would say, and very committed to athletics. So it's a nice blend of personal interest and personal excitement about this technology. As I said, our oldest boy is a junior at FSU. He is he's on their inline hockey team, so he plays for FSU hockey. Our second boy is currently playing high school football, and he swings competitively. And our youngest boy is playing travel baseball, so we cover the gamut. Scott Andrews, he has 2 boys. They're both baseball players. Scott is on the board for the local KRH, it's Keystone Recreation Association. They manage the children's sports programs. My wife is actually president of that group on a volunteer basis. Josh Hallberg comes to the team. He's an active athlete. He still plays competitive soccer, which is noble. Ladies could take it, but they can't anymore. Josh also understands the heartburn of leg amputees. Josh's father-in-law is a leg amputee and often refuses to wear his prosthetic device, prefers to sit on the couch because of the discomfort associated with that device. So he's pretty passionate about a better solution. We do have a board of advisors. We start with the inventor. Chad is the inventor of this technology of converting this foam. He's an associate professor at FSU and the High Performance Material Institute. That's where all of this work is taking place. Michael Plew, longtime friend of mine. Michael He spent 20 plus years, and he still is currently an executive. He's the Vice President of Quality and Regulatory for a tissue bank, not RTI, for one of their competitors. And he's on our advisory board. I just talked to Michael this morning. Walter Tovkoch, some of you may know Walter. He's been around Gainesville for a long, long time. Walter is our legal affairs advisor. He's 20 plus years in the legal landscape, a lot of commercialization, tax and labor law. That's really his area of expertise. And again, a longtime friend of ours, and Mark Ferris. Mark was the controller at RTI when I worked at RTI. We stayed in touch. Mark has agreed to be our financial affairs advisor. He's a 20-year veteran, controller, CFO, in the medical device space, understands that industry well. So not on the management team, but committed to be on the board of directors. So what's our marketing plan? Again, we've done little to date, and we're very busy with customers, which is incredibly exciting. So phase one, I talked about phase one, sheet-based product, sheet applications. What we have done is we've branded the phone, at least a little bit. 3 of the top 10 sports companies and footwear companies have contacted us. We're in dialogue and providing prototypes for all 3 of those. 2 medical device companies. We have not phase 2, but phase 1 prototypes. Just touch and feel samples. What do you think? What do you think about the technology? Where would you apply it? So we're in early discussions with 2 different bracing companies and 1 military protective gear companies that talked about their interest is they've got a Kevlar ballistic vest, and what better behind Kevlar than another Auxadyre material in terms of this foam. So it's second level evaluation with those folks. There's a phase 2 marketing strategy. This will be mid-year 2016, as you saw on the timeline when the prosthetic stock development project comes to fruition. We're going to leverage the $4.5 million VA and the $500,000 Army. Our intentions are to market directly to the VA and become their preferred supplier. With the DALC, the Distribution and Logistics Center in Colorado, is where a lot of the VA products are housed and resourced. VA insured patients can call, get online directly and get products from the DALC. They have 2 prosthetic sock suppliers in play today. We intend to be the 3rd, and we're going to get we intend to get some clinical buy-in that this is a superior solution. Once we have that, we intend to expand out into the broader non-VA insured patients through an e-commerce strategy. Again, those prices are fixed. It's a CMMS reimbursement rate. The 2015 reimbursement rate for prosthetic socks, again, is $78 and some change, and patients are entitled to 6 socks every 6 months. So there's recurring revenue once we get clinicians and patients convinced this is a better solution. We are a minority-owned company. My wife holds 51% of the company, so we should have some good discussions with the VA and getting that preferred vendor status. Startup expenses. So here's where we've been since April. In Q1, we spent about $36,000 getting to where we are today. We've actually spent a fair amount of the $67,000 depicted for Q3 and Q4. Again, that's been all bootstrap, and we knew going in that we're going to do a lot of the heavy lifting early on our own, and we're prepared to continue to do that. As we get into mass production, there'll be a big investment as we get our first supply agreement and not only the geometries, but the exact material properties nailed down with our first customers, and so there'll be some hard tooling expenses. But we think by the end of Q1 will be about $275,000 invested. That will have us in a mass production state creating revenue. We do show positive, you'll see the P&L positive EBITDA and positive cash flow for calendar year 2016. So the ask again, $600,000. We intend to pursue the state of Florida matching fund of $300,000. That gets us plenty of runway. If we are unsuccessful and produce 0 revenue, these funds will carry us through 2018. We will not commit the $63,000 until we have a supply agreement. So we'll continue to build prototypes and try to sell and market the idea. We don't believe that's going to be the case. We have very good dialogues with our customers. In fact, the customer that we think is at the forefront asked for about 25 sample pieces for a ladder development project that they'd like to pursue. They flew all the way from Seattle to Tallahassee to spend a day with us and the inventor team. The director of material science, we had great discussions. Level 2 prototypes are being built as we speak today. And his comment to me was, this will be the last freebie that we ask from you. The next discussion we have, assuming that the test results continue to show promise, will be a commercial and development agreement. This company makes 5 million pairs of athletic shoes a year. It's 10 million shoe inserts. From a P&L standpoint, again, a very conservative look at 2016. We believe about $250,000 of revenue, putting up about 10% EBITDA, and growing pretty rapidly. So in 2016, initial applications in medical device and initial applications in sports equipment are our focus. As we get into 2017, we believe we'll be supplying a pretty sizable stocking order to the DALC for the Veterans Administration, and that generates a pretty big revenue jump in the device space, and continued mass production in the sports equipment space. We get into 2018, we're going to expand prosthetic socks through e-commerce and sell to patients directly, in addition to the VA and the non-VA insured. We have some smart foam technology that we think comes to play and comes to market in the sports space prior to medical device, because we don't have to deal with the FDA landscape. And we get that technology commercialized and proven out. 2019, additional applications, additional customers. The applications of foam pads, the list goes on and on and on and on. I assure you, all of you, as you sit here right now, maybe with the exception of 2 of you that are on the wooden chairs, you're interacting with 2 phones right now. One of them is in your shoes, one of them you're sitting on.
Are you at 24?
Oh, you're right, I'm sorry, lost track of that. So this would be
I
the
thought it was
last.
gonna ring. I think we have to stop.
Stop, okay, that's fine.
I thought that was gonna ring at 20.
Yep, I should have. I did a count up, not a count down. I apologize.
That's okay.
I apologize. All right, good.
All right.
Okay.
Well, we'll start from left to right. So Kevin, if you want to start, and then we'll swap around and ground.
I just wouldn't mind hearing a little bit more about your competition, if there is any. I got the impression that you have sort of a lock hold in this manufacturing process. Are there other people working in this space that could bring to bear different kinds of manufacturing processes to achieve the same type of end product? Or?
So the last run at our Auxadyre foam was done by MIT in conjunction with Exeter University in the UK. It's a published paper if you go on the internet, it's about 6 pages in length. They filed for a patent because they had discovered a process that they could make Auxadyre foam large enough for mattresses, which pressure relieving mattresses would be an ideal application for the technology. 1999. About 4 months in, they pulled out and canceled the application because it was a chemical-based process. Chloroform was the converting agent. They couldn't get the chloroform back on the foam. Our process is ambient temperature and inert gas. And we wrote a patent around the process with boundary conditions about this wide. We tend to manufacture it about this wide. So we think it's incredibly protected. In other applications like football helmets, there are lots of companies looking at geometries, including air pods, where they extract air as part of the energy absorption capabilities. That would certainly be a competitor to the business plan. In addition to the 3 major sporting companies, we've been contacted by 2, and they have prototypes. So they're design restricted to the behaviors of conventional foam.